2013 Canadian Open Mathematics Challenge, Part C. In the diagram, triangle AOB is a triangle with coordinates 0, 0, 0, 30, 40, 0. Let C be the point on AB for which OC is perpendicular to AB. Determine the length of OC. Okay, so let's realize that this is on a coordinate axis. That's why they've labeled it. And from Pythagoras, you can easily figure out the lengths of the hypotenuse. Well, this is a length of 30, and this is a length of 40. So you can use the Pythagorean theorem, 30 squared plus 40 squared is equal to AB squared, to figure out that AB is 50. So that's going to be 50, the length from A to B. And then they want you to figure out OC. Well, OC, they're saying is perpendicular, so that's a right angle right there. Okay, that shouldn't be a problem. The area of that triangle is 1/2 base times height. Now we can use this as the base and that as the height. And when we do, we get 40 times 30. We can also use this as the base and this as the height. So when we do that, it'd be 50 times OC. So this basically becomes 40 times 30 divided by 50, so which is 4 times 3 divided by 5, which is OC. Sorry, 4 times 30 divided by 5. And that's going to be 120 divided by 5, which is 24. So OC is 24. So that takes care of that part. Determine the coordinates of C. So they want me to figure out these coordinates here. What is that? Okay, well, let's take this one step at a time. Let's first figure out what is the slope of that line AB. That slope is rise over run, so that's going to be 30 minus 0 over 0 minus 40, which is negative 3 over 4. Now OC is perpendicular, so OC's slope will be the negative reciprocal of that negative 3 over 4, which is 4 over 3. Okay, so now we can figure out the equation of the line OC. That's, as always, y is equal to mx plus b, but m we have just figured out is 4 over 3. And then let's just substitute any point on OC. Well, we have that point, which is the origin, so b is equal to 0. So the equation is really just y is equal to 4 over 3x. That is the equation of the line OC. Okay, so now we can try to figure out the coordinates. So that means that this line, or this point C, is x, y, but y is 4 divided by 3x. Okay, and then we also know the distance from O to C. We calculated that already, is 24, right up there. So we can use the distance formula that x minus 0 squared plus 4 over 3x minus 0 squared is equal to 24, all under the square root sign. That's just a simple distance formula. So that means that 24 squared is equal to x squared plus 4 over 3x squared. So 24 is equal to, what's this, x squared plus 16x squared over 9. And therefore 24 is equal to, 24 squared. So that's 9 over 9, so that's 25x squared over 9. So therefore x squared would be 24 squared times 9 over 25. So x would be 24 times 3 over 5, correct? So that means x is equal to 72 over 5. Yeah. Okay, 72 over 5 is x. Now we have to figure out y. And I guess I just substituted into here, right? So y would be equal to 4 over 3 times x, which is 72 over 5. So that's 4 times 72 divided by 3 is 24 over 5. So that's 96 over 5. Okay, so that means this coordinate is 72 over 5 and 96 over 5. Okay. Let M, part C, let M be the center of the circle that passes through OAB. Determine the length of CM. All right, so what they're saying is that there's some circle that passes through like that. And they want you to find the length from C to M, where M is the center. So I guess M is right here. Now, you might say, well, how do you know that M is on that line? Well, remember, there's a rule that if you draw a triangle within a semicircle, and if it has a right angle, then that means that this is the diameter. So I guess they've sort of done it in reverse, in that they've already told you that this is a right angle since these are perpendicular, and therefore that triangle would create a line that is a diameter. So AB is the diameter. So AB is the diameter. So that's why I know that the center, which they are calling M, is on that AB. So that's how I know that. Okay, so I guess the distance from C to M would be easy if we knew the coordinates for M. Well, M is the midpoint of AB since it's the center. So the midpoint, we just use the midpoint formula, I guess. So M would be 40 plus 0 over 2 and 30 plus 0 over 2. Yeah, that's it. So that would be 20 and 15. So there you go. 20 and 15 are the coordinates. So now we just have to figure out CM. Well, that's easy because we have the coordinates for C and the coordinates for M. The coordinates for C are here, and the coordinates for M are there. So using the distance formula, 20 minus 72 over 5, all squared, plus 15 minus 96 over 5, all squared, all under the square root sign. So that's going to be 5.6 squared plus 4.2 squared, all under the square root sign, and that's 31.36 plus 17.64, all under the square root sign, and that is 49 square root, and that of course is 7. So CM is 7. Determine all real solutions to a squared plus 10 is equal to a plus 10 squared. So a squared plus 10 is equal to a plus 10 squared. So a squared minus a, 10 minus 100, so minus 90 is equal to 0. And I think this should factor. That is going to be a 9, 10, positive, negative. So that means a is either negative 9 or positive 10. Part B. Determine two positive real numbers, a, b greater than 0, such that a is not equal to b and a squared plus b is equal to b squared plus a. So a squared plus b is equal to b squared plus a. Okay, so let's put this all on one side. So a squared minus b squared, just that part, and then this is a minus b. This factors very nicely into a minus b and a plus b, and this is a minus b. Now the a, they tell you that a does not equal b. So if a does not equal b, then that means that we can cancel these. So all you're left with is just that you have a plus b is equal to 1. So that's pretty much it. So any pair of positive real numbers that have a plus b equal to 1 will suffice. So a is equal to b, 1 minus b. So for example, if I want any such pair, I can choose anything for a. So let's say I chose 3 over 4, and then b is 1, a is 1 minus b, or b is 1 minus a. So if a is 3 over 4, b would be a quarter. So there's just one example. Part C, find all triples that satisfy a squared plus b squared plus c is equal to b squared plus c squared plus a is equal to c squared plus a squared plus b. Okay, so let's figure this out now. So we have a squared plus b squared plus c is equal to b squared plus c squared plus a is equal to c squared plus a squared plus b, right? Okay, so I guess we have a few equations here. The first one, of course, is these two. A squared plus b squared plus c is equal to b squared plus c squared plus a. And then we can equate the first and the last, so a squared, or it doesn't really matter what order you do it in. The second and the third would be b squared plus c squared plus a is equal to c squared plus a squared plus b. And then the first and the last would be a squared plus b squared plus c is equal to c squared plus a squared plus b. All right, so let's move forward with this. So the first one, okay, so the b squareds cancel on both sides, and all you're left with is just a squared minus c squared, and on this side, a minus c. Factor again, a minus c, a plus c, and that's equal to a minus c. Now, we don't have any restriction this time, so this basically means that either a minus c is equal to 0, which would mean a is equal to c, or it means that a plus c is equal to 1, and that would mean that a is equal to 1 minus c. Okay, so that is our first sort of finding, I guess. Next finding, very similar, I guess. It would be b squared minus a squared, and this would be b minus a. And again, it would factor in a very similar way. B minus a, b plus a is equal to b minus a. So this would mean either that b is equal to a, or that b plus a is equal to 1, meaning b is equal to 1 minus a. Okay, and then in the last one, since now you're an expert, this would be b squared minus c squared is equal to b minus c. And very similarly, b minus a, b plus c, and that equals b minus c. So that basically means that either b minus, this is b, should be b minus c, is equal to 0, meaning b equals c, or it means that b plus c is equal to 1, and therefore c is equal to 1 minus b. All right, so we've got a few scenarios here. We can choose anything for a, but for b and c, we've got a few different scenarios. We've got scenario 1 here, scenario 2 there, this guy, and then we've got 3 would be this one here, and 4 is this one here, that b equals c. Okay, so when we combine these, we can choose for any fixed a. We have to figure out what is b and c going to be. So there's a few combinations, and not that many. The first is if we have, let's say, we choose 2, this guy, we have to choose one of these 2. So I'll choose 2 and 4. So 2 and 4. And then the other one would be 2 and 3, obviously. And then if I chose 1 on this, it'll be 1 and 4 and 1 and 3. So these will give us my triples. Okay, so 2 and 4, A is fixed as A. 2 tells me that B is equal to A, so this is also A. And then 4 tells me that B is equal to C. Okay, so that's also A. Okay, so that's an easy triple to figure out. So that takes care of this one. Now this one, again, A is fixed. 2 tells me that B is equal to A. So that means this is also A. But then 3 is a little bit different. This tells me that C is equal to 1 minus B. So this will be, so C will be 1 minus B, but B is A, so 1 minus A. And now we look at 1 and 4. This guy, 1 tells me that B is equal to 1 minus A, so that's going to be 1 minus A. And then 3 tells me that C is equal to 1 minus B, so C is equal to 1 minus B, but B is equal to 1 minus A, so that's going to be 1 minus 1 plus A, which is just A. So there we go. This is my third one. A, 1 minus A, and A. And that takes care of 1 and 4. Actually, I think I did 1 and 3 there. Okay, no problem. We can do 1 and 4 finally. A is fixed. 1 is this guy right here, that B is equal to 1 minus A, so this is 1 minus A. And then now we do 4. 4 just says that B is equal to C, so C is equal to whatever I put for B, so that's 1 minus A. So there we go. We got A, 1 minus A, and 1 minus A for 1 and 4. So these are the triples that satisfy these equations for any fixed A.